Today, I think we have our own fabulous Yee Tong is going to lead a workshop on how to create Flytekit plugins. And then I think we'll have some time for a little Q&A after that. And maybe we'll talk for a little bit of talk with Keithan about what's coming up in the next month. And with that, I will turn it over to Yee.
Sure. Is this coming through for everyone? I will assume it is. Okay, cool. So this is, I guess, the start of a maybe not the first formal, I guess, Flyte workshop where we try to go basically more of like a hands-on tutorial type demo, or rather than a demo. So as you know, Flyte works on a type system, and the typing engine in Python is pluggable. So that is what this talk is about. By the end of this talk, you should be able to understand what the type engine in Flytekit is and how its transformers work, and be able to use them to convert between Flyte types and values and your own custom Python types, classes, and values. Why would you want to do this? You would want to do this because you want to, maybe you have more complex data structures that help define your business domain, or you have like pre-existing types and objects. And if you implement the transformation, then you get the rest of Flyte for free. So as you know, the Flyte system in general is defined in the IDL repo. The types in particular are in types.proto. So specifically, a type is defined by this one message, literal type. So a type in Flyte is one of these protobuf messages. Yep, that is that. The Flytekit type engine is responsible for converting between a Python value and a Flyte value, and vice versa. So for instance, if you have a Python integer 42 that you get by like x equals 42, how do you convert that to a value in Flyte? That is the responsibility of the type engine. This conversion, by the way, happens for every single task for run at the beginning and at the end. Basically, at the beginning of the task, the engine will convert from the Flyte value to the Python value. Your Python code will run, and then the output gets converted back into the Flyte system and pushed down the line. The type engine operates on registered transformers, and it provides the following interface. There is a function called toPythonValue. That's what you call if you're given a literal, and you want a Flyte literal, and you want to get a Python value out of it. You also have to pass in the Python type. So this type engine relies on the annotations still being there. There is a function toLiteral, which does the opposite. So given a Python value, a Python literal, and the Python type, and the expected Flyte type, you get back the Flyte literal value. And for a given Python type, also the transformer the type engine will tell you what the Flyte type is. And there's some additional functions in there, but these are the main ones. And how does it do that? It does that through this type transformer system. A type transformer is a generic base class where T is the Python type that you want to build your transformer around. So if you want to use this, you should first subclass that base class, and then implement the following. Get literal type. This is just returning the Flyte type for your type. toLiteral, so given the Python value, how you construct the Flyte literal, and then the opposite. And if possible, you should also implement guess Python type. Basically, given the Flyte type, this function by default just raises an exception if you see the type that you are interested in and you believe you can accurately return it, then you can do so. What I mean by that is, for instance, schemas. A Flyte schema can come from any number of things, so it's not really possible to know what the original Python type was. But simpler types, or perhaps you're a custom type, you can do this. So, and this helps back out. The Python interface from a Flyte interface, and that's useful in some of the Flyte remote cases. Once you've written a transformer, you have to register it. So there's a bunch, all the basic types, integers, strings, floats, time deltas, whatever, are also based on transformers. Those are the default ones that come bundled with Flytekit, and they are registered automatically. And then some others have to be triggered manually, which is why, so schema comes bundled with Flytekit, but just in case you don't use it, we import all these in the init file. And then also there's a new plugin feature, I guess. So for Flytekit plugins, you can add your plugin to a setup.py entry point that Flytekit will then automatically load. So if it's installed in that virtual environment, it will get automatically loaded if Flytekit is triggered, I believe. So demo, there's actually a fully featured example for this already that we'll be walking through. This is in the Flyte user guide, also known as Flyte Snacks Cookbook. So pretend you have a data class, pretend you have the class myDataSet, which is a custom type. This one is constructed to represent just a bundling of files into a folder, and it comes with a couple properties and this new file function, but this can be any object in Python. So if you want to convert between this and Flyte, you can write one of these transformers, which subclasses type transformer, and you have to first decide basically what the Flyte type will be. So in this case, we've picked blob. Blob types are so named because typically they are stored on a blob store like S3 or GCS, and they have a string called format that is part of the type, not the literal, and a dimensionality, which can be either a single or a multi-part. Since we're working with folders, multiple files, we decided to go with multi-part. You give it your transformer a name, and then you implement these two functions, two literal and two Python value. In this case, because we're working with files, basically we're uploading and downloading to and from the blob store, to and from your local file system. Since the Python literal value basically represents a series of files, you have to upload and download that data. Registration happens like so. So you call type engine.register, and then you can use this just as you would any other type in a workflow or in a task. And assuming the transformer was implemented correctly, local workflow execution and local task execution should still work. And I ran this yesterday on a local Flyte sandbox, and you can see the first task generates and the second task consumes. So, and basically we're just writing a line into each file, but this is the output of the first task. And if you were to look in the browser, you would see these files. If you were to download them, you get the thing. And yeah, that would be it, actually. Do I have more? Yes, so there's some existing transformers that are a little bit more complicated that you can look at. So schema is the most complicated probably among these, just because the transformer itself has an engine aspect to it, so that it can convert from a variety of schema types, including Spark, into the Flyte schema. Okay, then anything to add?
Yeah, so I think the most important thing over here is that transformers were added for higher level, like really complex data types mostly. For example, a LiDAR data type, or maybe you have a way to represent blood samples, and traditional columnar structure like a schema is not the right data structure for it. Maybe there's some better representation. Like for example, for matrices, there could be a CSR style representation, or some other, like for maps, there's like a way to compress big lines into like polylines. So you could really write polylines as a type that's available to your users, and convert the polyline to an underlying binary format or a file, or however you want to represent it in the backend. And this way, the goal of Flyte is to make sure that the users can code in the business domains that they really like and wish for, while not worrying about how the transport is being handled. And then the transport has to be done once, right? You convert it to Flyte known entities, and then Flyte will take care of the transport. This being said, we also heard that recently that folks would like that if I have a normal Python object and I don't want to annotate it with a data class, I should be able to transport it between two Python functions, Python tasks. And so we're soon going to support pickle-based transforms, but pickle-based transforms are very weak because they're shallow. They, like, if you have, let's say, a reference to a file and you want the file to be transported to the next task, that's not going to automatically happen because pickle really doesn't know that this is a file and I need to take the file and push it to the backend. So it will be limiting, but it's really useful if you're both the tasks are in Python and you can just move the data between them. So so we are going to support that, but pickle is also not as efficient as actually transforming it into a very known quantity in Flyte, because Flyte then can optimize, can compress, can store. Like for example, the columnar schemas are stored as a Parquet file. So much better optimized format than as compared to just a regular pickle of a NumPy or a arrow object. So that's how transformer started, and I think we've seen great use of it. One of the cool examples is Pandera and Great Expectations. I would really advise folks to go and look at it. It allows us to assert data quality at the point of like usage, which is really where the assertion should happen. It's like a gRPC service with validations on it. That's how we think about it. So yeah, but nothing else from my end. We would love suggestions, ideas, more contributions here. Like new data frame formats can be easily added. I think there is a couple of issues. One talks about Modin, another one talks about Wakes, another one talks about Mars. So yeah, we would love contributions in this. This is a different domain which allows you to specialize Flyte for different scenarios. We'd love that.
I guess one last thing that I forgot to add. If you implement one of these transformers, you also can, Flyte will automatically handle conversion of lists and dictionaries of that point containing those types.
Yeah, because they are like a composite types automatically. Lists and dictionaries are containers, and they can be containers of any arbitrary known transformers. So that's a great point. Yeah, that's it. I think one other thing we wanted to add was like what are we working on, and the core team here, mostly all of us who've been contributing. So I think I'm really excited for this release coming up end of this month. We have a native scheduler in Flyte. So this is cron and fixed rate scheduler, fixed rate scheduling. No need to configure anything in one of the cloud providers. Just use Flyte and it comes. Even on Sandbox, you should be able to schedule stuff. We are working on improvements to the remote API that we just released recently. Lots of improvements. Thank you for all the feedback. It really helps. We are also working on some enhancements in the total backend system. We are working on adding MPI and Snowflake plugins. Snowflake will allow you to query Snowflake tables and use them in Flyte functions. And MPI is to run distributed training jobs. Not only distributed training, any distributed MPI jobs. And we want to make it really easy for most users to not think about how to start the containers, how to bring them in containers together, and so on. So that's all will be handled by Flyte. And I'm sure there are a few other things that I'm missing. So I think, there's a big update in the documentation, not a docs, but like how users write documentation for their workflows, tasks, objects, and so on, how that gets represented within Flyte. It's a big story. It's ongoing. We're constantly working on it. I think the backend will be in place, but the front end will take some more time for it. Yeah, and we are really looking for feedback on what aspects should we prioritize. And we have a huge backlog. You can look at our issues and stories, and there are lots of them, and every day many are created all the time. But prioritizing means, with open source it's really hard. Like I find 4 things really cool and I can go and implement them, but it's better to know if something's really blocking you, then it's better to bring it up, and we would be happy to help. Anything anybody else wants to add that I've missed out? Haytham, do you know something that we're working on that I missed?
We merged, I guess, recovery mode a little while ago that didn't make it yet to the release. So that's also coming up end of this month. And that I don't think we demoed that, but I think we have heard people ask for something similar, and I think it will be pretty cool to try it out. And it does set the stage for a few new cool features to add afterwards. I think we should schedule a few demos next time, maybe quick, few minutes to demo like these features coming in this release.
In the UI as well.
Yeah.
That's going to show up. I think we've solved the problem of when you're trying to input JSON. We now have a automatic form generation for JSON inputs for people that are doing, sort of manual hyperparameter inputting when they're rerunning the workflows. So we've beefed up the UI team a fair amount, so that you'll start to see some changes from those guys coming in soon.
Yeah, I think it's shaping up to be a big release.
And Great Expectations is also part of this release. So and lots of Flytekit enhancements here and there. So as promised, every month we release. This release is end of August. Next one will be end of September, and I think we are in a stage where we are rapidly going to expand our integration with the systems that are around, because I think the core's been heavily worked on already, and we think we are in the peripheral integration phase. That doesn't mean we'd stop working on the core. It just means that we get more bandwidth to work on a lot more integrations. That's it.
Thank you, everybody, for coming. We will see you in a couple of weeks. And thank you, Yee, for that. That was super clear, and it's super nice to see the docs like shipped when the features shipped. That was great. Big improvement. All right.
All right.
Good week, everybody.
Bye.
Bye-bye.